Okay.
Like for Lime Sign 3, everything has to be made by me?
Um, you're on a GDW team, so I'll allow it doesn't have to be specifically you, but try and submit the pieces that were made by you. I imagine typically how we'll break it up in GDW is like one person will work on environments while one person works on characters, kind of thing. Let's see here. Let's see.
Can I submit things that were partially made by me? Like I made the block out and then another group finished it?
Sure. Yeah. Submit the block out to me. Let me know, and then we can see how it progressed. Okay. Hopefully that opens quick. While that's opening,
I say block out. Basically, I did everything except the main body of it, so.
that's all right. Yeah, just upload the stuff that you did. But yeah, it's more for the environment stuff I'm worried about, less anything else. What week is this? 11? Oh my goodness.
I know.
Yeah, that's crazy. So we have literally this class
And next week.
and next week. So yeah, it's gonna be tight. Which means I'm gonna have to go like high level overview kind of stuff with you guys here, because there's just no way to cover everything. But this will be the important stuff.
For the diorama, do I need to make the ground?
My biggest concern with the diorama is just seeing the pieces made with the techniques that I'm going to show here today and have been showing over the last few. Even if the diorama itself is not the prettiest, as long as like the actual assets are made to standard, you're good. Right? Like I don't expect you to have the same level of environment that I'm putting together. That's a lot for you guys to do. But it is for GDW, so if you do want to go above and beyond, right, it's only helping your game. Oh, it's not on. What's going on? Also an aside, just for now. Oh, bright. Short office hours today. I've got summer to be, so I'll only be at the lab till like 4:15ish. But if you wanted like extra feedback on stuff, you can find me there today. All right. So today we're going to talk about some new stuff, some old stuff, some stuff you may or may not understand yet, but we'll get there. It's going to be trim sheets, materials, UVs mainly, and that'll sort of lead into how our environment looks. It's going to have a huge impact. So this is the beginning of our texturing. So we've done our modeling, right? We've done our block out. We've done refining our block out. We're getting into the details now. So here we are. So this is week 11. Yep, UVing, textile density, trim sheets, tileable materials. I'm going to break it down with you, and we're going to take a look at how shaders work. I'm going to be using Unreal, but really it applies to anything. And then next week should be our final kind of lighting, and I'll show you how to make it into a portfolio-worthy piece. And then, yeah, after that, it'll just be you guys kind of going about doing that for yourselves for the final assignment and for DDW. So, yeah, here we go. Material setup, custom shaders, UE5, trim sheets, how to make them, and UVs. So hopefully you have time to get through everything today. If not, I might put out some async stuff. So let's talk a bit about shaders and what materials are. So there's usually like this misconception because not a lot of people take computer graphics. I'd highly recommend you do because it really helps you understand this stuff. But so what is a material? Our materials are actually instances of shaders, being just code that handles our graphics. So there's a infinite number of ways that you can create these shaders, write these shaders, do whatever you want in them. The core way to do that in Unreal Engine is through the material graph, and Unity similarly has their shader graph as well. So you're going to want to get very familiar with this. I'll be using Unreal because it's flexible, and that's just because that's what the project was kind of made in. And you'll see kind of what these are going to do later, right? So our materials are actually just instances of these shaders. Okay. So when you're working in something like Substance Painter, and you go into the viewing settings, right? Because you want to change what your material supports. It's because you're actually just changing the shader, right? And that's going to handle all those different maps and parameters differently. So what a material is it's actually an instance of a shader with some set parameters. And those parameters usually fall into things like base color, roughness, metalness, all that kind of fun stuff, right? Stuff you're very familiar with at this point. So I'm going to walk you through most of what I've done with shaders for this project, just over the top there, as we get through today. And the world is truly your oyster with that stuff. You can do whatever you want. So here is kind of like a default PBR shader setup. This is like very typical stuff, right? Base color, roughness, metallic, normals, emissive, ambient occlusion, which we're not going to use here really because Lumen doesn't support it. But anything that you want to do, that you can do mathematically, you can put in this shader, right? So very common parameters we give ourselves when we're making these shaders are going to be like adding a tint to the base color, right? We can make any mask and map we want. We're not limited to those 6. Those are just kind of like standard ones that you make as you go. But the workflow is up to you to determine. I could make RGB masks to mask out different parts of meshes using the same material to change things up or blend different things together. I could make a triplanar material that's going to cast different materials on different surfaces of objects to texture really large things in world space. I could do an edge mask, right? Maybe each object, instead of UVing it specifically for its material, is going to just have a second UV set that just highlights the edges. So I could have procedural edge damage or something like that, right? World space adjustments, randomness, vertex color material blending, Y-up dust shaders or snow shaders, anything you can think of that you can put and operate between pixel and screen pixel, you can do in these shaders. So again, if you haven't taken CG, I'd highly recommend it. It really helps you kind of grasp what's going on with this stuff. Thing is, if you want to be an environment artist in industry, you're going to have to learn this stuff anyway. Like this is part of your job. So whether you learn it through just making these shaders over and over, or whether you learn it through taking CG, up to you. But it is something you're going to have to do at some point. Okay. So we use the shader graph in Unreal, and it's using nodes. And there are a few nodes that are super common, super prevalent, that we're going to get familiar with today, if you aren't already. The main ones that we can just put any basic shader together are going to be our base color, or sorry, our parameter 2D, which is just a texture sample. Our texture coordinates, which tell us which texture maps we should use. We're going to talk about multi-UV setups as well today. So all the props that I've made have 2 UV sets, which might sound a lot right now, but it'll make sense later. A vector 4, right? A vector 4 we can treat as a color with RGB channels followed by an alpha channel, right? So it shows up as a color and everything. We can read it as a color, but in reality it's just a vector 4. And we can replace that with any mask we want, whatever we want to do there. Multiply nodes. So again, we got to think about this mathematically. If we're taking like 2 images or 2 vectors and we're multiplying them together, right? So very common, as well as lerp. So linear interpolation you should be familiar with from like Mathematics 1 and everything. You will use that a lot as well. If you want to take 2 materials, for example, and let's say you want to blend between 2 materials, right? You can use a lerp to blend between those materials. So in a lot of games, let's take God of War, for example, you might be looking at the terrain on the ground and they have like, oh, there's painted dirt pathways connected to like grassy areas, right? How are they getting between the dirt and the grass and making it look nice? They're lerping between it with some other random noise and functions on top, but at the end of the day, it's still a lerp. So these are pretty powerful nodes, and we'll get to using them later. So the question when we're developing our shader is, what do we want it to accomplish? We're familiar with a lot of the basic ones. There's default PBR opaque, then you have like default PBR but with opacity or translucency or whatever you want to add, right? So in this case, I'm going to go through with you today setting up a fairly basic PBR material, but then I needed mine to do a lot more, so we'll get into that in a second. Okay, so let's talk about textures. The big thing I need you to know about textures is textile density. I've talked about it throughout the year, about on your props and everything, but now we're doing it on a much larger scale. So we've got objects that are in world space, taking up real world space, that have actual dimensions, and our pixels need to sort of match up with those dimensions. So there's an issue when you unwrap in Blender. This is not an issue in Maya. Maya actually supports like textile density based unwrapping, but as far as I'm aware, Blender does not yet. So if you were to just click on an object by itself and unwrap it, it's automatically going to try and fill up the bounds of that space, right? It's like Blender's just like, yes, I unwrapped this object. I want to fill the UV map to the best of my ability. But let's say you have objects of different size. These objects are all filling that UV map. I unwrap them individually. So they all fill that UV map, but now I've got wildly different texture sizes. And that's a problem, right? You can tell just by looking at it how off it is compared to equal density. So after I unwrapped these ones, I went and set my textile density to be even across all the meshes, right? And you can see we get the nice evenly sized squares all throughout. So why is this important? Well, one, detail, right? We don't want things to start looking super pixely as we get close to them. And two, more importantly, is the size of our details. So because they're pixels and they're taking up physical space, let's take this texture I made, for example, just as a demo. We have all kinds of little pebbles and sticks and rocks and things like that. So let's take a look at the non-equal example here. If we look at the small cube, you can see really tiny, look at that, they got like little pebbles and stuff going on there, little sticks and everything, because it's maxed out its density. Then we move over here and we've got these really big pebbles and large sticks, and it's not the same size. My textile density is not the same, so my sticks, my stones, they're all different sizes, and it becomes super jarring super quickly. It doesn't matter, sticks and stones, it's whatever you're working with. We can't stray too far from this. Let's say you're doing grains of wood, right? You're gonna have one thing that looks super duper grainy and one thing that doesn't look grainy at all, and it's gonna be really weird. If we come over here to the equal detail side, right? All of our details are the same size, plain and simple. You have a stone here, it's the same size on here. You've got a twig there, it's the same size on there, right? Our details are gonna remain the same size. So it's pretty important that you get this stuff right. And there's really easy ways to do it. There's an add-on that will basically do it for you. And we'll get to that. There's actually a lot of add-ons. It's very important, and Blender hasn't added it yet, so the community has gone and added a ton. So after I talk about trim sheets, so this is going to tie directly into that as well, that last idea. So what is a trim sheet? Does anyone know what trim sheets are? Have any of you used them before? You're familiar-ish?
I assume it's a sheet that has trims on it?
Sure, but you need to know how to actually use them. Okay, so let's talk about these. So trim sheets are going to be your way of keeping your textile density consistent across your props. What they allow you to do is repeat details across some dimension. A lot of the pieces we build for our environments are going to be long in some direction, right? Because we want them to take up as much space as possible. Imagine a railing. Do I have any railing here? Okay, imagine this thing.
How about these?
Those would work too. Imagine this thing, right? So this thing's really long horizontally, but vertically, it's kind of short, right? So rather than texturing this, let's say I wanted to UV unwrap this and have it be even textile density, right? Look how long it is. If my map, I'm not going to be able to like get a good coverage with this map. It's super long, so if I'd have to like cut it up into like a bunch of different pieces if I wanted to see, and then I get ugly seams and everything, right? Or if I have detail that repeats in one direction, so in this case, I have detail that repeats in one direction. Instead of treating this as one big object, I'm going to treat it as a few different faces. So let's say we have this front face, right? This is the one that's facing you. On the top here, we have this top face. So if I have a trim sheet where I've got one piece of trim that's as big as this piece here, I can run that infinitely and I can make it as long as I want. It will repeat and the textile density will remain the same across the entire length. And I can just pick a different part of that map for the top. It's a slightly larger size piece of wood. I'm going to show you exactly what I did with this in the Unreal environment. I made literally one trim sheet. And that is what I've used to texture every single object in the scene except one. And you'll see how much we can get away with just one. I'm also going to show you an example from Skyward Sword, and they do something similar. So look at this. This is all made of one texture. Dude spent time making one single texture, and now he can texture any prop that roughly fits those dimensions, right? We don't want to spend all day texturing a million different assets. That will eat up the most of your time when you're doing environments, so we're really trying to avoid that. This is the way to do it. The other advantage, of course, is these are all now on the same material. They get the same draw call. So, boom. Instead of having 8 different materials for 8 different pieces, I've got one. Same draw call, all happens in one render pass, 10 times better. Gary, what's up?
Okay, so just curious, Is that from the ancient sister from Skyward Sword?
No, this isn't from Skyward Sword. This is just a random example.
Oh, okay.
So it might be from the ancient system.
Definitely not.
I'm just looking at the poll. It looks like the left picture is similar. But I also want to ask, when you make trim sheets, like, do you like never mind, because I was looking at something because a lot of people were talking about how like they would like layer some stuff on it or making it.
You have to layer stuff on it. You have to make sure they're roughly the same size, right? We have a little bit of leniency with the textile density on these, but not a ton. I'll literally show you exactly how I use them later, though. You do have to texture them, which takes a lot. But here are trim sheet UVs. This is how UVs look when we're using trim sheets, right? So very, it goes against everything you've learned so far. I know. This is specifically for environment art stuff that we're going over this. Again, super important though. We'll explore when and where to use this. And this is also why we're going to start using multiple UV sets. Because obviously, what would happen if you tried to bake this down, right? You cannot, because it is exceeding the 0 to 1 UV space. So we'll get to that in a bit. This is typically what it looks like though, right? So you can see I've got one repeating element, and then it can just repeat infinitely around that one axis. Okay, so let's take a look at some of this stuff. I'm going to use Nintendo as an example before diving into our project and looking at that as an example, assuming Unreal actually opened. So this is Skyward Sword, and this is NoClip, a website where they take a bunch of these. Let me double check. There we go.
Oh, there it is.
Okay, so
Welcome back to Boundary Break, where we basically take the camera anywhere we want.
that's basically exactly what this is. Why is it stretching like that though? That's weird. Let me refresh. That's very unusual. I don't know what that is. It might have been, okay, I guess it loads resolution based and I just had it open on a different computer. So let's take a look at some of the stuff that Skyward Sword does, how they use their trim sheets, how they use their materials and shaders, what their kind of workflow stuff is. You'll learn a ton by going and looking at these kind of things. So let's take a look quickly at the trim sheet stuff. I need the Goddess Castle. So let's take a look at this little section I want to show you here. And we're just going to examine all of our repeating elements, right? So we can get an idea of how this works. So like I was saying, we're almost always on these big environment pieces going to have some level of like areas where we can break them up into thin, long strips. So here, we can break this piece up, right, into a big, thin, long strip that runs across like this, right? And that's just repeating detail all the way down, right? So we could say, hey, this part of the texture that we made, that's going to go on our trim sheet. What next? Other repeating details. We've got these like little stone bits that run around in this loop, right? And they're probably just repeated. This is cut up into like 3 different UV sections, right? Another piece is going to be this tone up here. That's repeating along this thin, long strip. And so rather than having, all of this UV'd flat and manually textured, this is actually UV'd like this, where it's got a long strip across here, and then this is a long strip, and then 2 more long strips along the top with the different textures, right? You can see just how much we get out of this 1 or 2 trim sheets. So let's actually take a look at those, right? I'll show you these. If we go to textures, it should be under wall, or is it castle wall? There we go, right? So they've made 3 variations of trim sheets here, just to keep things a little loose, a little light. And you can see how small these are, right? 128 by 256. They're not even square, right? Because they're repeating so often horizontally, they don't even bother making them square. They just make them vertical so they can get enough trims to fit, right? So if we look at that one texture, we know like, hey, this little section here, these 2 pieces are repeating. And if you look closely, right, you can see here's a gray blemish, and then 2 over, here's a gray blemish, right? Because it's just repeating along the bottom, right? So fantastic. That's how simple it is to get these sort of trim sheet details set up. And again, we'll go through an example later. But then there's this issue of you're using the same texture over and over. We need some way to break it up, right? And this is totally up to you. You can do it any kind of way you want. In our project, I went ahead and started making RGB masks for objects that allow us a lot of control over different elements of them. Their decision, because this was on the Wii back when they wanted to optimize, they actually decided to use vertex colors. So they literally, all of the shadows that you're seeing right now, all of the ambient occlusion, all of the depth,
Baked in?
not even baked in, literally hand painted in the vertex colors, right? So let's get rid of the vertex colors. Wow. Now you've got all those flat textures that we've been looking at, right? NoClip doesn't have lighting, so there's no lighting in this scene. Great. Maybe it's super obvious now that these are repeating because it's just, it's flat lit. And just by painting on these vertex colors, right, and multiplying the vertex colors into the textures, we get a lot of different effects. So what they actually did, they did two things with their vertex colors. One, it applies a color overlay to the textures underneath to work for ambient occlusion and even cast shadows. This is a crazy optimization, but if we go over, we can see that where is it?
Are you trying to look at shadows right now?
Yeah. So look at these cast shadows, right? They're literally painted into the vertex, right? So you guys know about vertex coloring or whatever, but it's just another way that we can use the data available to us. So they chose to multiply that color in. You don't have to do that. You can do whatever you want with those vertex colors. Another example you could do is have the vertex colors cause things to fade out. So you'll notice along here we have like this beautiful sort of what we call skirts. So this skirt is to just kind of help this rock blend into this grass, right? Because normally this would just be a hard crashed object through another one, right? Which can look kind of ugly. So we have these skirts here. But you'll notice if I undo the vertex colors, right? The skirt's just a separate mesh. And they've just painted the vertex color all around the edge. And where they have painted it, they're going to fade that object out, right? They're going to multiply that into the alpha. So if we enable it again, you can see it's faded out here. And if we get rid of the textures, right, you can see literally where they've painted that out, right? So this is all the vertex colors in the scene. That's just how they've chosen to go through and about this, right? You can choose to do this too if you wanted to. You could choose to do any method, really. The main thing is you need to understand how we can take data and just use it to our advantage, right? So we have things available to us. Vertex colors is one, different masks are one, object world position is one. I actually use object world position to make a text shader for doing all of the stuff in the scene. Okay, so that's the Skyward Sword example. So with that said, hopefully that gives you a quick overview, good idea of what's going on here. I forgot to close this down from yesterday. Just put it here for now. And we'll get into our, where is it? Why is it not showing? Okay. So we'll pull this up right away and we can take a look at some stuff and what we've got going on. So let's start with materials. And man, I don't know if I'm even actually going to be able to show this very well because my computer is struggling. OBS is killing it. So let's take a look at some of the different things that we have set up here. Let's go to the default. So you can see right off the bat, I've got different little prefixes for different things. So let's talk about what those are. Here we have MF, and that's going to be a material function. So this is essentially just like any code function. It's just a little string of nodes that I could drag into another graph and reuse. So I've got an MRA function for just splitting up my MRA map, which we'll talk about that in a bit, and then a mass Z up. So let's look at this. Let's look at this function, right? So it's a pretty simple function, but it's just taking the normal map, and then it's just, right, so the normal map, it tells you which direction each pixel is facing. So we can figure out which way is facing up. So we can grab what's facing up, and then in this case, right, like I just wanted to isolate that part. And you can do anything, right, with this small material function. So in this case, I used it to make dust procedurally on top of my objects. I don't want to go in and texture dust on the top of all my objects, right? They're all going to have dust on top of them. I might as well do it in the shader. If I was doing snow in an environment, I'd be doing probably the exact same thing, right? I would use this as my base, and I would start to build up on top of that to get snow, because again, snow always sits on top of things. If you wanted to do dust in the crevices of different objects, right? You could always go calculate the AO or use the AO map to do dust procedurally in all the crevices and things like that. Lots of options, right? So let's go back to the actual material now. So next is MI. So MI is just going to be a material instance. And that material instance just means you've gone to your shader. So MM, master material, or shader graph, whatever you want to call it. And you can create a material instance. So like I was saying, a material instance is just a shader that's been instanced and then has properties, right? And we have the ability to create and highlight different properties that allow us to change the materials. So this is currently the PBR graph where it's at the moment. It's very simple right now. There's still a lot to do, but so we look here, we have a UV0 slot. So this is our first UV slot. This is where all of our trim UVs are going to go, and I'll show you that in a second. Right. And then we're going to plug those UVs into our base color, right, with a parameter for tinting, so we can change the color of the base color, right? We can make it darker, we can make it greener, we can make it lighter. How do we do that? We just take our tint color and we multiply it into our base color, right? Anytime you want to make easy adjustments to a color node or parameter 2D or texture, whatever, you can just take a tint and multiply it in. And you can see that a lot. So here's that procedural dust bit. So I've got a color parameter for the dust, so the artist can go in and change the color of the dust. And I'm multiplying that into a dust noise. And this is, again, similar. So they can change that noise to whatever different texture they want to affect how the dust sits or how it looks. And we can multiply that in, right? And then we're going to alpha that into our ZUp material function that we created earlier. Okay. This next section I did is RGB masking. So we have one UV set that's showing us where the trims need to go. And then this is a second UV set that's helping us blend between different materials. So I haven't set up the different materials yet, but I've just set up colors as a temporary. So dirt. I've given these objects a unique mask for dirt in Substance Painter that highlights where I would want dirt to go. And if I make a dirt material, I can just plug it in here. Edge color, right? I've made a separate mask that highlights the edges so that I could add a material that's like a more damaged wood or a more damaged version of the trim sheet, and it can slot in there to have those edge damages, right? And color variation. This was just a choice that I made. These are the three things that I chose to plug in because I knew if I wanted one more map, I have RG and B channels I can use, right? You could do anything with those three channels. I could put, like, I don't know, specifically paint strokes or something into one mask, into one channel. And then I could put like an up gradient into the other channel, right? You can put whatever you want. So I put color variation in here, again, just multiply it in by some amount and then lerping between them. So these are the nodes you're gonna need to get familiar with the most. Multiply to kind of combine things and then lerp to move between things. Right? And these all just go into our standard outputs. So beyond that, you're also familiar with roughness maps, right? With metallic maps, all that good stuff. But we can actually do something called channel packing. And that's essentially where we take a bunch of these maps and just stick them together. So I'll show you do that in Substance. It's easier in Designer than Painter, but whatever. So in this case, I chose to make an MRA map. You might have heard of an RMAO map, MRA map. It's just a bunch of the different materials combined, right? because your roughness is one, it's linear, right? It's grayscale. So let's actually crack this open so we can see. So this is all the textures I have. I have one for the repeating like wooden floors, and I have the trim sheet, and then a mask for the letters and stuff. But that's it. This entire scene is made up just with those and adding those variations. Let's look at the MRA, sorry. So why is it called MRA? If we take a look at our channels, right, MRA is going to line up with RGB. So if we click on the R, so I'm just looking at the red channel now, this is our metallic map, so M. Obviously it's pure black because this is wood. There's no metallicness, so it's whatever. Honestly, because this whole scene is just wood, I don't even really need a metallic map. I could have put anything else here, but metallic it is. Then if you look at the green channel, this is my roughness map. So the R from MRA is going to be the roughness map. Typically you want to put the roughness in the green channel because the green channel holds the most info when it's compressed, but there we go, right? So this is my whole roughness map. Because it's grayscale, I can just shove it in the green channel and it works just fine, right? And then B.
Why does the green channel hold the most info?
I don't know the exact specifics. It's just like how it breaks down when it's compressed.
It's probably because it's in the middle.
I'm not exactly sure. I don't know the math behind it. But then yeah, B. So what does RMA stand for, right? What's the A stand for, right, Ethan? Ambient occlusion. Boom. Again, useless because lumen, but we just put it here for this like posterity. Right, there you go. So my ambient occlusion is in my blue, my roughness is in my green, and my metallics in my red. So then in our material, we just set it up that way. I'm going to slot my red all the way down here into metallic. Boom. Slot the green into roughness and the blue into AO. Right? So all in all, pretty simple premise. But the reason we want to do this, or reason why we can do this, is just it's less exports. It's better memory-wise. It's just easier this way. So I highly recommend you get used to channel packing. If you're using Unity HDRP, they have a specific channel map format that they like to use. I forget what it's called at the moment, sorry. But I know it's there. Unity URP does not. But you can, just like in Unreal, right, where I'm making this material graph, you can just go make a material graph in Unity that also has channel packing, right? It's really up to you. It's super flexible.
Apparently there are several reasons for why the green channel can hold the most information. For example, it is the color that the human eye is most sensitive to.
I don't think that has anything to do with the
light
computer.
in it and has less noise than the red or blue channel.
Less noise is probably key. The whole like human aspect of it, though, I don't think the human aspect matters because it's grayscale.
I don't know.
Okay, so let's keep going. So let's take a look at this now. So what else can we do with these materials? So a second thing I knew I needed was we've got this text here, right? How we could typically go about doing something like this text is you'd have to like export this with the UVs in one place. And then you go over here and you export this one with the UVs in the next place. And then you go over here and you export this with the UVs in the next place. But really, there's no point in doing that, right? I don't want to deal with a million meshes. I don't want to deal with a million different textures with the different letters on them, right? So what can we do? We know that these planes are going to be in different space, right, in world space. And because we're working on a grid of 400, we even know how far apart they're going to be. So if we make a mask material with even spacing, we can just calculate everything to happen in world space. So let's take a look at this. Right. So very simple. It's literally just a mask. It doesn't have any color information. It's just on the red channel. It's just black and white. And I've just got a bunch of evenly spaced words and letters and a flower pattern I haven't made yet to go on to our objects. And to combine with that, we've made a material graph here with all very similar stuff. So ignore this for now, right? But we take our mask, that's the idea. We add some kind of tint to it so we can change it later, right? Why would I even bother like pulling this into Substance Painter and making it all like gold and everything? I can literally just take the mask and fill the parts that are white with a color, which is what I do, right? Super easy. If I want to change it, I can change it in Engine in seconds. And because this is such a low like cost node setup, it's basically free as far as the rendering is concerned, right? And something as simple as this. I know I'm using this for letters, metallic and roughness. I might as well just make them little sliders. It's going to be even throughout. They don't need depth or textures on them. And you could even add that here if you wanted. I could multiply a noise in. So what else do we do? So over here, I'm taking the texture coordinates, right? And what I decided to do is instead of making a bunch of different versions of the asset, I made one single one, put the UVs at the very top. Let's take a look at that. So if we come down here, I've got just a clear plane with some text on it, with another plane behind that's green. And I've just got the UVs set up here so that they're in the first position on the text. So let's take a look at that. Right, so boom, there it is, UV's first position. Now, just like in Blender, if I start moving this UV around, it's going to move, you know, which part of the text is going to show. So in this case, what I chose to do is just every 400 units of world space, it's just going to move this down to the next position. So if I go GY007, right, I've moved to that next position, so -007. I can replicate that exact same thing here. So here, all I've done is take the object's pivot point location, which is going to be its world space position. I mask out, mask you can just use to separate channels. So I'm grabbing the G channel, but remember, we're using colors to represent just numbers, right? So this is a vector 4. The G channel is actually the Y value, like, because this is the world space position. So then I can divide the Y value by some offset, in my case 400, because that's the size of my grid. And I can, for every 400 meters, multiply that by 007, right, which is that number that we came up with earlier. So this way, I've only put in Engine this one single plane. I don't have to repeat it a bunch of times. I don't have to change anything. But it will move the UVs, right? So I'm adding that new position to my existing UV position. So this is all the same material. It's all the same UVs. It's all the same object. But I can now adjust it however I want. So let's open that back up. So here's my material instance, right? You can see all the stuff I've exposed. So the distance between, and I've set it up for Y and Z because later I have letters that go alphabetically upwards. And I'm gonna do the exact same thing. I'm just gonna change the Z offset to be a smaller amount, and it will just cycle through those letters as it goes up, right? Because again, I don't wanna unwrap and export a bunch of different ones. So here's our, our UV offset, and we can literally change this. So if I start to change this, you can see it's literally sliding everything around. And it's going to slide differently depending on how far away from world center these things are. Right? So there we go. Now I've got different text showing up all across as we go down, with the same object, the same texture, the same UVs, okay? If you can think about some mathematical way to solve your problem, you can do it in a shader. That's like the main thing I'm trying to get across to you. So let's dial back a little bit and keep looking at our trim sheet setup. So how do we make trim sheets? Basically, we're gonna wanna start thinking about anything in our kit. So you guys have this, right? We're at this stage with you, I've kind of made it here. We've all got modular kits now of our pieces that are tileable and that we can reuse. And let's take a peek at how we can break some of this stuff down. So if we look at this railing, for example, we can kind of treat, this plane as a long strip and put that on our trim sheet. Maybe this top bit is something that can be trim sheeted. Let's go to the bookshelf. This long strip, we can trim sheet that. This long strip, we can trim sheet that. If it's a long strip that you can break down, you can trim sheet it. Super simple in premise, right? Even this table, We have this long repeating detail around this edge. We have this long repeating detail around the side. So we can put this in a trim sheet too. And again, even this pillar to an extent. There is a little bit of, I haven't quite figured out what to do with the top, but the bottom, if we just focus on that, right? Again, long repeating detail around the side, long repeating detail around the side, long repeating vertical detail, right? And on the side as well. So let's take a look at the UVs for this stuff. Here's the UVs for my table, right? And to actually make sense of it, you kind of got to put it on the bake. So, right, you can see how I've got a bunch of different wooden strips of different sizes, right? Some are smaller than others. A few different variations of small ones, slightly larger ones, and then even larger ones, right? All throughout, to try and get as close coverage to all of our different parts as possible. And then on the top here, I've got different sections set up for specifically those facades, right? Because we have a lot of those really intricate details. So those have all been added into this trim sheet as well. How is this trim sheet actually made? Once we have a rough idea of the different size pieces we need, and in this case, I didn't really measure it. You could and probably should measure it to get a good idea. You can just, let's say you find a face you're going to trim later. You can grab it, duplicate it, and just move it over to where you're building your trim up against a flat plane. And that's mostly what I did for this stuff here. So if we take a look at this, you'll see I just have a bunch of these flat planes that I kind of extruded back to make to give it a bit of thickness. And then once these are all stacked, I can export this as a high poly or all right, so in this case, I set this up with a driver. So if you don't know what drivers are, basically they let you control other parts. So I gave this flat plane just a subdivision thing, and then I hooked all of the assets on top of it up to a subdivision controlled by this. So these are super low poly right now to keep my file happy, but if I click this, it will activate the sub D on everything at once, which is super convenient. And now I can take this model detail, export it into a program like ZBrush, to give it extra depth. So you see I have this like sculpted in edge damage. That was done in ZBrush. You can do that in Blender too. It's just a little bit more finicky. Once you have created something like this, you can either go and start UVing, because I know that these are now constant. I cannot change the size of these because I've already got UV unwraps that fit these sizes. I cannot change anything about this trim sheet. That's the one downside. It's static at this point. I'd have to go re-unwrap anything that needs redoing. But once you have that all polished, you can begin to texture the trim sheet as if it was an object. Let's get 3D Painter open here, and I'll just show you the kind of stuff that I did to this trim sheet to give it its color, right? But it's just like anything else that you would do, right? Any other object you would texture, except this time it's just a flat plane. Trim texture. So once you have your actual mesh stuff set up for your trim sheet, you're just going to export it with a flat plane. This is literally 4 vertices. It's just a flat plane, and we're treating this flat plane as if it was the texture itself. So you remember I was talking about trim textile density and making sure it's all real world scale, and everything that we have is set up to be 4 meters. Well, what do we have here? We have a plane that is 4 meters long, right? If you guys remember, we set out to do 512 pixels per meter. So this plane, which is just a square, if I was going to turn it into a texture, it'd be one single 2048 map. So when I bake all this down, I just bake it down to one single 2048 map. And you can see in Substance Painter here, I've got one single 2048 map, and it's literally just on this plane. right? But all of our detail is coming from those maps that we baked, right? So just like here, or just like normal, we go bake those mesh maps with our high poly, and then we can bake our normals, our curvature, whatever else to give us the information we need to texture it, even though it's a flat plane. Right? I'm not going to bake it again. It's already been baked.
Question about lab assignment 3. How much detail do we need to go into if we are using GW assets and our thing is more low poly?
Then maybe don't do it for how low poly? Like my game jam game low poly, or like just optimized?
Like I have a dome, which is just an icosphere that I cut the bottom off of, and then did a bit of insetting stuff. Like,
is it going to be textured or just use base colors?
Well,
I am going to need to see like
constraints. It won't be textured.
Right. Okay. I'm going to need to see textures and things like that on these pieces. So if it's something like that, then find a small project you can kind of do on the side to make these modular kit pieces for. Doesn't have to be super big, but yeah, because I am going to need to see things like textures and an understanding of these workflows.
Well, there's going to be textures just on things that aren't not the dome.
Right. Again, I don't think that'd be a great use case for things like trim sheets anyway, though.
Well, no, I'll be using that for other things.
Sure. There's always ways to use them. Like everybody should have at least one.
Yeah, there's stands because it's a racing game.
Right. So you could use it for that.
Could you use it?
I'll get back to that, but I got to get through this.
Right. Which we call it thing for like texture cards.
That's a different thing. I haven't talked about that, but you could as well.
Cool.
So, right. So just like texturing anything else, we start to texture this plane. So I've just got a few different wood materials that are sort of building on top of each other. And then we go in and can do all the details. So there's some scratches that have been added, some thickness darkening, right? So we're just taking that curvature map, or that thickness map, sorry, that we baked, and we're filling the thickness parts with a brighter color. Some color variation as well, just to keep it interesting, right? I'm not going to talk too much about the texturing. You guys know how to texture things. We've been over it enough times. Adding some edge damage, some dust, etc., etc., etc. Oh, I will talk about this. So this is something that comes up often, but we're thinking about our materials as if they're built up from nothing. And it's the same here. So I was really struggling to get how their wood has this very like unique, it has a lot of color showing through, but then a lot of darkness as well. It's very contrasty and it's not very common in wood. And I tried to recreate it through the wood as like so many times. And I eventually just caved and Googled it and found that the wood that they used here, they had actually torched it black. That's how they got that contrast and everything. Suddenly, it's now 10 million times easier to make my texture, right? I make a colorful wood, and then I torch it black, right? Following those real world procedures, whether it's for this wood or for your lighters or for anything else, it really, really helps you kind of get to those desired results, right? So now I've got all these torch bits and that color that's shining through in those different areas, and it looks way more effective than just where it was before. Okay, yeah. So again, you can texture yours however you want. It's a trim sheet, do whatever you want with it. And then once we have that, what I like to do is use the base color, just to give me a decent idea of what's going on. But if you take the base color in here, right, so here it is, I can look at it in Blender and start to unwrap my models to that. So let's go start unwrapping things. Where's some good examples? Let's take these for example, right? I've got these railings. I'm going to want to start breaking these up into different pieces that can be trim sheeted. So, you know, here along this side, right, we can think of this big long face as one plank of wood, right? And I've got a bunch of different planks of wood that I can choose from. This one actually got a very special plank of wood because it's got these engraved details in it. You can see here, I've got this plank here, and my UVs are just filling that plank. But I could take this and I could duplicate it and kind of move it over, right? And it will just keep kind of repeating itself as it goes. So, right, it's going to tile infinitely along. Yep.
So I understand like trim sheet is for like repeating doesn't make that much sound right here for part of it. Like, if we just, the mesh itself is repeating, then what do you do?
The mesh itself is repeating? I mean, it's the same thing, more or less. So like, again, we've been working, right? And because it's an environment, I know all of these pieces are 4 meters long. So I made my trim sheet 4 meters long, just cause. So now every single one of these pieces, it will tile perfectly. As long as the UVs, like this, right? It ends right on the side. It will tile perfectly because my trim sheet tiles perfectly, right? So now, even though I have these pillar things in between that are breaking it up so you can't see it anyway, I know this would tile perfectly because it's 4 meters long on the dot. GY4, no, GY400. Alt D GY400, right? So it's going to tile perfectly because that is where it kind of, that's how it's been set up. So it'd be the same thing. If your mesh repeats, like, you just got to make sure it's sort of matching, right? And so, okay, let's take a look at another part, right? We've got this like ornate wood detail on the inside here. So all I did was I took this piece, I duplicated it, separated it, and then took this down to where my trim sheet was and just placed it somewhere on the trim sheet where I could then go in and add my sculpted detail, right? So that's how you're getting things to be the right size consistently throughout. So now I know that the textile density on this, it's like pretty even, right? So that's how I also know that these are exactly perfect end to end. Not everything is going to be exactly perfect end to end. Let's take a look at like, I believe there's other pieces that are not. Bookshelf maybe. Pillar. So the pillar is a lot more complicated, right? It's got all these little nicks and crannies and everything like that. But when I'm actually making it, I say, no, that's one plank of wood, right? Keep it simple. So in my actual unwrap, right? Yeah, but here is one plank of wood. And again, to keep things consistent, I made this 4 meters long. This bit's 4 meters long, fits perfectly on my trim sheet, right? And what happens with the trim sheet is because we were adding these edge damages in between, hello? Okay. Because we're adding these edge damages in between, let's take a look at something like this, right? So this part, the edge of it is ending in this little, where the edge damage starts. And this top piece, it's ending where that edge damage starts. So then, even though this is just one single hard edge like this, right? I can keep my topology super simple. So I've got one hard edge like this, but if I back away from it a bit, those two edge damages create a fake, like, rounded part of that corner, right? So now, even just from like this far away, it looks like there's more rounding and damage, and this looks a lot higher poly than it actually is, right? Super simple overall. So yeah, but again, you have to make sure it's not on the ends. We're doing it, just tiling it in one direction, right? So I went ahead and unwrapped basically every single prop like this. These facade pieces, right? Let's take a look at the seams, right? Look how many seams there are, but it doesn't matter because of the way we're building the trim sheet. We've got this section for these eggs, egg and darts, right? And that's gonna go along the egg and dart part. Yep, Ethan?
So you unwrap it twice. How do you like keep both of that, like both information pieces?
So if you go down here to data, you can actually add new UV maps. And whatever one you have selected is the one that will sort of show up here.
That's the one we export with?
It will export with both.
Oh.
There are some issues and caveats, which I'll hopefully get to here in a second. I'll talk about the RGB masking. The one issue too, though, is your seams do not. You can't have two sets of seams. You only have one set of seams. So I'm gonna have to redo this later. But here's the thing: is when you're unwrapping for trim sheets, I can just select these faces and just unwrap them by themselves. I don't really need seams on trim sheet unwraps because it's only gonna unwrap the faces you select. So if I select these three, right, and hit unwrap, it's just unwrap these three, totally separate from everything else. I can then go ahead, come in here, go to textile density setter, right? I've got it set up at 512. I can hit set. That makes it the right size, and I can rotate it. Right, let's find a piece of wood that's like of a similar thickness, right? It's always better to kind of scale down, because if you scale your UVs down, that means your textile density is going up. So you're better off increasing the detail when you can than decreasing it. So for me, I'd say like this one's pretty close. I'm just going to scale it down until it fits on that plane, and then boom, you know, there it is. I've got that strip cut out, but it hasn't affected anything else. So that's how that would work. And then the UV seams I would save for the actual UV maps. So earlier when I was making that material, I talked about how there's different stuff in the RGB mask. So we can take a look at that example as well before I go and make one. There's a lot of information to cover, so sorry it's a little bit all over the place, but trying to get through all of this is not super reasonable in an hour and a half. There we go. So this is just an instanced version of that material we made, right? You can see all the same stuff's kind of sticking out. And I've got this additional one. So this is just an RGB mask, and I went ahead and made that in Painter. I'll show you how that's all set up right now, actually. But then I can lerp between different materials in these channels. I can just color tint, right? All I did was color tint. So what effect does that have? Let's come down here. You'll see, even though this is using the same material, I've got this like bright orange kind of coming down here. That's just coming from one of my masks. So if I go down here to color variation, let's say I make that green, you can see it's now green in here. So the core of this object is still going to be using that tileable trim sheet, but the different details like this I can control separately from the material. So what else did I add? I added dirt. So there's a dirt mask in that second UV set. And we can change the amount of dirt. So let me just crank this just for demo. And you can see the dirt mask, right? All the areas that would have dirt in them are now filled with this bright kind of yellow. And that just helps break up the tiling and the repetitiveness of that same material. So, you know, we can adjust this. All right, just adjust the opacity of it, plain and simple. Okay. Same with the edges, right? It's literally the exact same thing. So how do we go about making that next part? So let's go through and do that for something I haven't done it yet, so we get the whole like example. We can do this facade. So I know I set up my material. My first UV map needs to be the trims, like you can see here. So I'm just going to quickly rename this to trim UVs. Then I can add a second map, and the second one is where I'm going to put that RGB information. And one last thing is, because we use lerping in our master material, so getting that master material set up is super important because it defines everything else you do. But because we're using lerping and it's a math function, I'm not using pixels. I'm just lerping between the different colors, right? So this object, to match the textile density, right, I'd have to do something absurd. I'd have to give it a whole 2K map, yada, yada, yada. But it doesn't matter because it's going to lerp between the pixels anyway. So we're not messing up the textile density by making a mask that's like, I could make the mask for this 512 and it would still look just fine when it comes down to the actual blending between the materials. That's how we're able to get away with this kind of stuff. That being said, for ease of time and everything, I don't want to change anything, so I'm just going to make it 2K because that's what I have it set up for. So let's go through and start to unwrap this, right? So by default, our second map here is going to be a duplicate of our first, so that's why it's still set up with the trims. Obviously, we cannot use the trims for this. This is where we don't want to have a ton of visible seams. So let's go through here. And I'm absolutely sure I don't want to change this trim sheet anymore. The unwrap on this is done, that first one. So I can get rid of all these seams. I'm just going to clear them. Something else you can do is just make a duplicate and have them share maps, but have different seams marked on them, kind of thing. But in this case, again, because I'm totally done with the trim unwrapping, I don't really care. And then, honestly, all I'm going to do is take this, and we'll mark some seams here and here. Let's give that an unwrap, and looks pretty good to me. Actually, maybe we need one here and there. We'll just double check our stretching. I don't think it's going to be that bad. I think this should actually be okay. Oh yeah, beauty. Right. So I might consider rotating this so it's oriented properly, but honestly, I don't even really care about that. I just want to make sure I've got nice space here to go and fill in those extra details. Despite what it's saying, I'm going to add one more seam here anyway. Yeah, okay. So now you can see, though, I can flip between these two maps, right? I've still got my trims. Unreal's still going to use these to show up my texture and everything. But this one is what I'm going to go make my RGB mask with. See, it doesn't affect the blender render unless you hit this little icon. But now, here's my other UVs. But again, they don't matter because those are never going to touch the trim sheet. They're only going to be for baking. So I'm going to go ahead and re-export this. So same old, library project, export settings, make sure it's consistent. Find meshes in here somewhere. Okay, or I'll just have to do it the old-fashioned way. Content, meshes. And you'll notice this time I'm exporting it straight into the engine. It's because we're not doing like bakes or anything. So I've told you in the past about how we want to use like OBJs to do our bakes and everything. We're not really baking this. We need that information for texturing, but we're not like giving it a normal map. That's not the point of this. We're making our own custom map. In this case, an RGB mask. So let me find that. This is just facade. Export. You notice? Nothing happened. Of course nothing's going to happen. It's still maintaining that first UV set, the proper one, right? So let's go back here now. Make a new project. And it honestly doesn't matter what we start with because we're going to delete everything. So these are Unreal templates, and they basically just set up how the masks and maps are going to work. We're making our own. We want to make an RGB mask. So I'm just going to hit by default the PBR metallic roughness starter. But yeah, it's not going to matter because we're going to remove everything anyway. I'm going to check here if I made the other textures with 2K or not. I did, just for the kick of it. Let's make this 1K though, just to demonstrate how it doesn't really matter. And we select our file. And I'm going to select this directly from the game files library. SM facade. Perfect. Fantastic. So the next thing we're going to do is go nuke all of the stuff they gave us. Base color, don't need it. Height, don't need it. Roughness, don't need it. Metallic, normal, don't need any of that. We're just going to add some new custom ones. So at the bottom here, you'll find user channels. And you can add whatever custom channels you want. So user 0. And, we'll just call this one R. And our dash dirt. That's where our dirt's going to go in. Let's make another one. Let's go user 1. So user 1 is going to be G, and this is going to be edges. Right? Again, this is whatever you want to put in here. And then user channels 2 is going to be B, right? So RGB, and then this one can be color variation. But again, it can be whatever you want. These are all by default 32, but these are all single channel, so we can just change them all to L8 because they're just linear grayscale. Okay. Next, let's bake our mesh maps just like normal, but this time we're going to hit use low poly as high poly. So I'm just going to click that and bake our select textures. Don't need ID. You know, we're not going to get any extra detail, but we don't need any. We just want these for the generators and stuff, right? So there's like a dirt generator that makes use of the ambient occlusion. So we kind of need that in here. So I'm not even setting up this file in like any way. The rendering does not matter. Nothing matters. We're just using Substance to make this RGB mask. Let's go to our layers now. You'll see we have red, green, and blue, just like normal. And you'll see if I come down here, right, where we used to have base color and all these different settings for our fill layers and brushes, we now just have R, G, and B. So let's make a mask. I'm going to make a new folder. Call this one dirt, and add a fill layer. So this is all stuff you should be familiar with at this point. Fill layer, and I only want this one to affect the red channel. And then we can go up here to material, right, single channel, and just look at dirt. Let's make this black. Okay, great. Now let's add a new fill channel on top, and this will be where our actual dirt comes from. So let's add a mask, black mask, add a generator, and honestly, I'm lazy. So why don't we just use their dirt generator? Boom, dirt, click, fantastic. Now I've got dirt, right? You can adjust this however you want. Dirt level, I'm gonna bring it down. Dirt contrast, I wanna bring that down too, right? It's going to go into all those little nicks and crevices because we used that curvature map, or we made that curvature map. Grunge amount, going to keep that down. Grunge scale, you'll have to adjust kind of, I can't tell just from this, right? This prop by itself, it's kind of hard. I'd have to export it first to see how it looks in space and then come back and do this again. Dirt level, maybe something like this, right? If we don't like it in some areas, we can always just add a paint on top and just start painting it out. Say this, for example, like I don't really like it on here. I don't know why it's on there. It doesn't make any sense for dirt to be there. Paint it out. Okay. Boom. Bam. Great. Now we can make another one. I'll call this one, you know, what do I put? Edges. Right. So edges, add a black mask, switch up here to edges, change this to G, right? We're just filling in the G channel. And this one, I'm just going to give a fill. And our edges are basically just a variation on our curvature. So curvature, you can see now I've got these like little bits of highlighting around my edges. And I just want to add one more underneath. There we go. All right, boom. So this is now my edge mask. So this is just the green channel. And there's like 10 minutes left. So I'm not going to bother with the last color variation channel, but it's the same process. You kind of get it now. Let's make a folder here. Folder. So we have dirt, we have edges, and we theoretically have underneath that color variation, right? So what we can do is take these three folders, right? Except I'd maybe get rid of the paint layer first. But we can take these three folders, and if I right click here, whoop, that's annoying. Oh, sorry. I have to put all these three folders in another folder first. So these three folders into a folder, and I'm going to call this RGB underscore masks. And if I right click here, we can go to create smart material. And that just creates an instance of these different masks that we made out. So create smart material. You'll see it shows up down here. Whoop. Right, so why do I want to do that? Well, you can imagine I have a lot of props in my scene. I got to run through all of them this exact same process. But if I make the nodes procedural like this, so that dirt node, procedural, the curvature node, procedural, right? Theoretically, the color variation, procedural. Instead, all I have to do is open the prop with its UVs being proper, bake it to itself to get those maps I need for texturing, and then just drag and drop this mask on, and boom, I have my RGB mask for that prop. I don't even need to save the substance file, because I know if I do that same 10 seconds process again, I'm going to get the same result. So then I would simply go to File, and you go Export Textures, and we have to build up a new template. So Output Templates, I'm going to make a new one here. Again, we were ignoring all of these. I'm going to make a new one at the bottom and just call this RGB mask. And again, just to iterate, I'm doing RGB masking because that's the workflow that I am using. You would do whatever your little heart desires. If you can put it into a 2D map, you can use it. It could be height, it could be materials, whatever. RGB masking. And so what this allows us to do is basically this output maps button, it creates a new map, right? In this case, we need one new map, and I'm not using the alpha channel. So I can literally just hit R plus G plus B, and we have one map called RGB here. So it's called RGB underscore mask. And last thing I'm gonna do is you can use like swindling here. So I'm gonna hit the little money sign and then mesh underscore. So that little money sign mesh, if I'm not mistaken, is the hot fix for, it just grabs the mesh name and uses that. Yeah, so underscore mesh, dollar underscore mesh, or just dollar mesh. So this will export as SM underscore facade underscore RGB mask. But I don't want to put facade in here because I want to use this template on everything. So mesh just grabs the mesh name. Okay. Got to do that again because I accidentally tabbed out of it. So R, what's going in our R channel? Dirt. What did we set dirt up on? User 0. I recommend you do the order because for whatever reason it doesn't rename these. I know it's in user 0 because we did it like orderly. So user 0, I'm just going to drag and drop from gray. That's my R channel. User 1, let's go drag and drop that into G. That's my G channel. And then user 2, drag and drop from gray channel. And now I will get an RGB mask. Ethan, what's up?
What does from gray channel mean?
It just means treat it like linear. Because within here, these masks that we're building, they still have all 3 channels. We're using gray just because we made them linear.
Oh, so this is just telling it to do it like flat.
Yeah, exactly. It's just saying we don't need any extra information. Don't bother grabbing all 3. Don't bother grabbing the R, the G, the B. Just treat it flat, linear. So mesh matte, there we go. Let's go ahead and I'm gonna hit save settings. Save settings. Then I'm gonna go up here, and one more thing we have to do. Save as template. So you remember we changed all of our texture set settings, this stuff here, the users, everything. The last thing I want to do is save this as a template so that the next time we open a file, we can open it with this. So we can name it whatever, put it wherever, just call this one RGB mask. And let's actually export this texture finally, now that we've done all of that dirty work. So if we go back here to settings, right? Output template, boom, RGB mask, let's find it. We just made it, RGB masking. Export, I'll just put on my desktop for quickness. Export, boom, save. What do we end up with? Go to the desktop, an RGB mask, complete with our dirt bits, complete with our edge highlighting bits, right? If we put that into our material, in Unreal, right? We'll have those different materials show up where we have those different colors, or in my case, different colors show up where we put those different colors. Okay. And then let's say we want to move on to the new prop, right? Because we did all that dirty work of making the different assets, making the different templates. If we go new, let's just pick something else. Crystal ball. Nope. Anything but that, actually. Sorry. Curved roof. Boom. All the same stuff. Except we go up here to template. RGB mask. Click OK. We don't need that old file. It really doesn't matter. Here we go. Here's the next piece, right? Because we use that template, you'll see it all shows up down here, just like it would. RGB for that. So you could make a new one for every project. It's a simple process. And you'll see our smart material here, RGB masks. So let's say we want to do it for this one now. It's not UV'd properly, so it's not going to actually work, but use low poly, bake. Return. Again, this is not proper UVs, so it's not going to work, but this is the idea, right? Drag RGB masks on. There it is. And we're now done. So if we check the dirt channel, right, there's our dirt. Edges, edge highlighting, and the color variation we didn't do, right? But then, boom, export, and I've got my next one. So you can see how fast that is now that we've made all those templates. I can do that for every prop in our scene, and then we're kind of complete with where we need to be. Okay, and the recording real quick. But that's basically it, right? So that's how we can use all of these different little techniques to speed things up, to get our textures in and effective. By using trim sheets, we're keeping things light, we're keeping things quick, right? So even this big table, I just broke it up into 3 boards, and it's that same large board, and the only thing that's separating it is just a UV seam right here, right? We've got little details that are reused around the sides from these pieces and these pieces. So not only does that keep it consistent, right, but it keeps it proper. Okay, cool. So thanks, guys. Any questions real quick while we're closing this up?